Hello student, in previous lecture we see about the periodic trends in modern periodic table. The first periodic trends in modern periodic table is the valency and second is the atomic size, and today we discuss about the third trends in the modern periodic table, that is the metallic and non-metallic characters. Okay. Before starting our topic, if you like my video then please like, share and subscribe to my channel. My channel name is Sharda Survase. So now we start about our topic, that is the metallic and non-metallic characters. So basically we already see the whole modern periodic table. Their valency is also, and depends on this valency and their atomic size, they shows the metallic and non-metallic characters. Basically we know that the S block elements and P block elements consist, S block elements and D block elements consist of the metals, and P block elements is called as the means basically the P block elements, it consists of non-metals. We see about one zigzag line. We start from boron. Oh, this zigzag line represent that above that zigzag lines they shows the non-metallic characters, and below that metallic characters. In between this zigzag line they represent the semiconductors or metalloid characters like the silicon, arsenic. These all are the examples of metalloids or semiconductor example. So depends on their valency and their atomic size, we basically discuss about the two terms related to the metallic and non-metallic characters. The first term is the electropositivity of elements, and second is the electronegativity of elements. Okay, electropositivity of elements, and second is the electronegativity of elements. These both terms are opposite to each other. Basically in S block elements or D block elements consist of metals. Why we call it is metals? Because it having the free extra electrons in their valence shell or valence orbit. We know that what is meant by valence shells or valence orbit. The last orbit present in the atom, it is called as the valence orbit, because in last orbit it sometimes take electron from other elements or sometimes donate electron to the another element, and hence means these electrons, the outermost electrons or outermost orbit electron present in an element, they take part in the process of chemical reaction or in the process of reactivity. It is called as the valence shells. Okay, or these electrons present in the valence cells, it is called as the valence electrons. इसको हम क्या बोलते हैं? Valence electrons. So in electropositivity means the element easily donate their electrons and become positively charged. Okay, means donate their valence cells donate electron and become positive or acquired positive charge. Example, lithium. Lithium having atomic number is 3. So in last orbit of lithium consists of 1 electron. So it easily donate their last orbit electron. So this is the atomic structure of lithium. Here 2 electrons are there in first orbit. In their valence orbit 1 electron. So basically it easily donate their last orbit electron or valence electron and become lithium plus acquired 1 positively charged after donating the 1 electron. And this nature of element is increases along their groups in the S block elements, not P, it is the S block elements, because metals are highly electropositive elements, and in group first are the most electropositive elements in the periodic table, because this easily donate their last shell electrons and become positively charged particle. Like the in first group consists of hydrogen, lithium, sodium, then potassium, rubidium and cesium. So along the groups, when we see along the groups S block elements, along the first group elements, their atomic size is increases because the valence electron present in next orbit, and hence when we consider that this is the electronic configuration of sodium and this is the electronic configuration of sodium having the atomic number is 11. This is the nucleus of sodium. This is the first orbit electron, consists of 2 electrons. This is the second orbit of electron, consists of 8 electrons. 5, 6, 7, 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons are there. and in last orbit one electron is present. So their orbits around the nucleus is increases very highly, and there is means the distance between the nucleus and orbit is increases. That is the attraction between the extra electron and in between the proton present in the nucleus. This attraction is decreases, and when this due to that distance, the attraction between the positively charged particle and negatively charged electron is decreases. Hence, it can easily donate their last orbit electrons, and it become a positive in nature or electropositive in nature. When any element donate their electron, they acquire the positive charge, and this nature of elements, it is called as the electropositivity. When we see the elements present in the group along the group first, that time the cesium, it is the more electropositive elements in the whole periodic table. Okay, Cs, the symbol of cesium is this, and this is the most electropositive element in the periodic table. This is all about the metal, and hence it is the good conductor of electricity also, heat also. Why it is good conductor? Because it consists of lot of free electrons in their valence orbit, and they take in the part of flow of electricity also and flow of heat also. These all are the electropositive in nature. Then next is the electronegativity. Think about the electronegativity. Both are opposite to each other. Electronegativity. So electronegativity means in their when we see electronic configuration along the periods, one example is there like the lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. This is the second group present in the periodic table. When we see their atomic size, when we goes from lithium to fluorine, that time instead of increasing their atomic size is decreases. Why it decreases? Because the one extra electron increases one by one in the same orbit, and due to that increase in extra electron, the nucleus, the distance between the nucleus and first orbit is the same. Okay, distance is also same, hence the attraction between the positively charged proton and negatively charged electron is increases, and due to this reason the size of the element is decreases along the periods. And when their size is increases, the attraction between the positively charged proton and negatively charged electron is increases. That time it is not easily possible to lose their electrons. It take electron from the other elements and become negatively charged, and become acquired the negative charge, and this negatively charge, it is called as the anion, and in electropositive they acquire the positively charge called as the cation. So we take one example like the oxygen. Okay, oxygen having atomic number 8. So in first orbit of the oxygen having the 2 electrons, in second orbit having the 6 electrons. So instead of donating this 6 electron, they take 2 electron from the other elements and acquire 2 negative charge on it, becomes O-2 oxide. Okay, their structure become O-2. When it acquired the 2 electrons, sometimes it may be acquired from hydrogen, sometimes it may be acquired from other elements. When it acquired the 2 electrons from hydrogen, then there is a formation of new compound, that is the water. And this nature of elements, it is called as the electronegativity in nature. So all non-metals, basically non-metals are present in the right hand in the periodic table, that is in the p block elements. So all are non-metals are there, and this is electronegative in nature. The most electronegative element in the periodic table, it is the fluorine, because in the last orbit of fluorine consists of the 7 electrons. It required only 1 electron to complete their octet. Okay, means every human being like to become stable or to means enjoy his or her life according to their stability or according to their lifestyle. And for their lifestyle they require the stability. Similarly, all elements in the periodic table, they also want their stability, and when they acquire their stability, when their electronic configuration is become like the noble gas. Okay, when the oxygen will take the 2 electrons from other element, that time their electronic configuration is become like the neon, and neon, it is the noble gas, means every element in the periodic table, they want the electronic configuration like the noble gases. When the lithium, when it acquired the, when lithium donate the 2 electrons to the other element, that time their electronic configuration is become like the helium. Sodium, when sodium donate their last orbit electrons, that time its electronic configuration is a 2-8, and that time the electronic configuration is 2-8, means it become like neon noble gases. So when every element in the periodic table, they want to become stable, so due to this stability, they sometimes donate their electron and sometimes accepting the electron from the other element. So it depends on their nature. Which are their nature? Some are electropositive in nature, means they donate their electrons and acquire the noble gas electronic configuration, and electronegative elements, they accept electron from the other elements and become a electronic configuration, become their noble gases and become stable. So this is the metallic and non-metallic characters of elements in the periodic table. And next is a very simple topic, gradation in halogen family. Gradation in halogen family means basically when we see the study of 1 by 1 group, that time they shows the similar property or similar characteristics. In a halogen family, the fluorine, chlorine, bromine and iodines are present. Okay, fluorine, chlorine, bromine, this is the different topic. Okay, fluorine, chlorine, bromine and iodines are present. Their state is different. Okay, so basically fluorine and chlorine, 2 are in gaseous state, bromine in liquid state and iodine in solid state. Means basically it is found in the nature. Fluorine, chlorine in gaseous state, bromine in liquid state and iodine in solid state. So due to this state of matter, or due to according to their state, there is a sees the one means gradation, means they are classified into these groups. Some are solid, some are liquid and some are gases, and this is known as the gradation in halogen family. So today's our topic is over. We stop here. In next period we see about the exercise of this topic. Thank you.